I love making soap. Soap making is a fun and useful hobby. I experimented with various molds, oils, recipes, mica powder colors, and fragrances. I also enjoy designing, modeling, and 3D printing soap dishes. My go-to mold has been a standard 42-ounce silicone loaf that sits in a wooden box. I often get pretty interesting results with partially mixed mica powder and oil added to the soap. But the soap slices have a tendency to assume a pattern resembling strips of bacon. I want to try making soap in the form of a slab and see if I can achieve different color patterns. I need to hurry up because we're almost out of soap. I don't have a slab mold, so I will have to try making one. First, I'm considering dimensions. My printer has max print area of 305 by 305 millimeters. I can fit 16 square bars with 75 millimeter sides in a 300 by 300 millimeter mold. I'm not sure if I want to have the mold dividing the bars, but I model dividers for reference. I bring this model into ZBrush along with a sculpting friendly slab model of the same size. I play around for a while using a mask on a subdivided model to delineate bars. Deformation modifiers will likely not do the trick. So I start sculpting the first square. I immediately recognize that this method is not going to be a quick and easy way to make a mold. Perhaps I should apply some alpha stamps? I'm thinking of a low poly look, kind of like this lamp. Let's try something else. I quickly sculpt the cube, then decimate it so that the polygon count is drastically reduced. I project the sculpted side of the cube onto a square in the mold. I like the result, so I thought, why not make the whole mold one big low poly terrain? And that's exactly what I've done. Next, I'm doing a bit of topology cleanup and replacing the messy sides with a fresh cube. Looking back, I can see that this could have been easily accomplished with Boolean's union. With character modeling for games background, I learned to strive for clean and efficient geometry. But that isn't always necessary, and it's pretty much irrelevant when model is converted to G-code. Here I'm adjusting the depth of peaks and valleys, considering print time as well as the look. Lastly, I'm deleting the bottom faces and extruding all the remaining faces together for thickness. As I bring a model into the slicer, I learned about the exclusion areas where extruder won't go. So I had to scale down the model bit by bit, supports extending into the exclusion area even if the model would fit. Travel lines got me a bit concerned here because TPU is notorious for stringing, and that's a lot to clean up. I'm applying adaptive quality, making layers of low poly as thin as possible for smoother slopes. And this will, of course, significantly impact the printing time. It will take a day and 2.5 hours with these settings. The print still goes outside the print area, so the last adjustment I'm making is turning off the brim. Finally, no errors. The G-code is getting sent to the printer, loaded with the purple TPU filament. At layer 2, I stopped the cheesecloth looking print because some lines got bunched up. There's some oozing, and at only 0.08 millimeter layer height, the extruder hits the globs and moves them. Instead of playing with settings and retrying, I decide to switch to PLA. That will eliminate a lot of problems with printing, but will make it more difficult to release the soap. Printing time is reduced to 21.5 hours, G-code is sent to the printer, and let's see how it goes. Alright, the print is done. It looks okay, but some cleanup is in order. There is some warping in the corner, and the build plate is stuck because it won't flex, so I let it cool down. The warping isn't too bad, and it doesn't affect the mold surface. Print is now coming off easily. Ooh, that's a lot of support to remove, but perhaps I don't need to, since it's out of the way. I want to check how flexible the sides are and see if I'll be able to get them to pop off the soap.
Go!
I kinda knew this would happen. I tried keeping sides together with Kapton tape, but ended up ripping them off completely. Testing hot glue, hoping it can keep it together while being easy to break off with some force. And it seems like that might work, so I'll go ahead and print new sides for the mold. The new side walls are printed. Due to the layer orientation and not just 6mm thickness, these walls will be much harder to break. But before I attach the walls, I want to spend a bit of time cleaning up the low poly print. I start with a 400 grit sandpaper. And I quickly realized that it will take me a long time to get some of these facets smooth. What if I use rotary tool? Spend some time outside in the sun, grinding off the imperfections from the print. When I had enough trying to improve the surface, I apply a few coats of clear enamel finish. I don't think that this helped very much, other than possibly sealing the tiny gaps in the print. I struggled a bit, trying to glue the sidewalls together. And it finally did all come together, although it barely qualified for a good enough category. Making a perfect seal between base and walls wasn't a big concern. It is because when the soap is ready to pour, it has consistency of muffin batter, not liquid. So the chances of it leaking out through a small gap are pretty slim. I'm calling the mold done, and now it's time to make the soap. Now, I won't be able to use the recipe I used previously because 36 ounces of oils will not be enough. And I'm also out of cocoa butter. I'm going to head to the soap calculator and make a new recipe. I'm thinking that 50 ounces of oils will be sufficient. I see that beeswax is listed. Perhaps I can use that for hardness instead of cocoa butter. 1.5% only of beeswax, then 5% of sweet almond oil, 5% of castor oil, and 29.5% of coconut, palm, and olive oils. Recipe is done and ready to print. Alright, let's go make 2 kilos of soap. Beeswax first. Getting the scale ready. Wax is pretty hard, and using peeler to shave it off is going to be tedious. So I switched to a knife. Sweet almond oil is next. And I'll add castor oil too. Then I'll add both to the pot. I'll use silicone spatula to get as much oil out as I can. It's coconut oil's turn. I need 418 grams of coconut oil. Adding it to the pot. Weighing the same amount of palm oil next. Dumping it into the pot with the rest. Lastly, weighing olive oil pomace. And now, all the oils are in a pot ready to be heated up. Turning on the heat on low. The last two things to add are water and sodium hydroxide, also known as lye or caustic soda. I'll need 538 grams of water. and also 202 grams of lye. Tearing the scale and weighing this food-grade poison. Lye is always added to water. The solution heats up and produces noxious fumes. I put on the respirator and gloves and open the window before mixing lye and water. I'm using infrared thermometer to check the temperature of the solution. The temperature of lye water and oils should be around 100 to 110 Fahrenheit when they get mixed together. I increased the heat to get the oils heated up a little faster. The oils melted, but the beeswax is still in chunks. While waiting for the temperatures to equalize for mixing, I'll prepare the colors. I do that by pouring a few tablespoons of oil into the ketchup cups and mixing in the mica powder. The first color I picked is ruby red. Then gold purple and bronze, but I replaced it with bronze gold, which turned out to be a bit too green. The mixing of mica powder and oil is a treat to look at because of the beautiful shimmering swirls on display. At this point, the temperatures of oils and lye water are about the same, so I turned off the heat. I used the stick blender to break down the remaining small chunks of beeswax. Check the temperature. Almost there. When the temperatures are around 105 Fahrenheit, the lye water solution is added to the oils. The stick blender is turned on in short bursts only, as I don't want the soap to thicken too much. What I'm looking for is the beginning of tracing. The mix starts getting whipped cream appearance. I'm adding fragrance called Secret Sandalwood. I always put way less than recipe calls for. Looks like I'm getting a strong enough trace, as the trail of the mixture is more defined. Going to stop mixing and scrape the soap mix off the stick blender with silicone spatula. Finally, it is time for the funnest part, pouring the soap into the mold. Adding the color and mixing it in, creating swirly patterns. Most of these color swirls won't be visible on the surfaces of the soap bars. The wonderful thing about this kind of soap is that it looks different each day as it is being used. The soap I'm adding from the pot has been hardening up, so I need to be quick. At this point, all of the soap has been scraped out of the pot and added to the mold. The top won't be flat, but will have an interesting, organic looking relief in contrast to its faceted bottom. I tried to make top surface horizontal overall, but there will be variation in thickness of the bars. Once done, I covered the soap with paper towel and dish towel and let it sit for 2 days. The soap feels quite hard by now, so I will attempt to get it out of the mold. I'm thinking that it might be just heavy enough to be shaken out of the mold. Clearly, that wasn't the case. I'm able to separate the side walls from the soap easily, but the glue holds them firmly in place. There didn't seem to be any other option but to take the razor and cut the glue. I did eventually get the side walls to come off, but I stopped recording, as I am sure you have better things to do than to watch me struggle. I let the soap sit for another day, then put it in the freezer for 2 hours. That finally allowed me to peel off the low poly part of the mold completely. I noticed that the tiny chunks of the soap remained stuck on the mold, leaving holes in otherwise nicely molded soap. If you know what could fix this, please leave a comment. Perhaps a glossy, sleek clear coat instead of matte finish? Or some mold release compound that wouldn't interfere with soap curing process. Anyways, I'm using a ruler to see where to make a cut, even though it's still mostly eyeballing. Lo and behold, the soap now truly resembles a slab of bacon. It's all fat on the low poly bottom and all meat on top. I never froze the soap before, so here are the two things I noticed that are different after freezing. There are tiny cracks near the cuts on top surface, similar to how the glaze on a cake cracks. There's also certain wetness and sheen, as if freezing pulled the water out to the surface. I can't help thinking of ways to improve the custom mold creation process. The low poly surface would look much better if I printed the mold in upright position. That would cut down the print time and filament use because I wouldn't need to print most of the supports. But due to the orientation of the layers, mold would be more prone to break while being peeled off the soap. It's because 3D print is the weakest along the print layers. And instead of relying on hot glue to keep it all together, I would model pegs and holes. Even better solution would be to use screws or nuts and bolts and make the mold easily reusable. I thought of oval tube mold with separately printed dividers so that each bar gets molded on all sides. I also have some composite mold that I haven't tried using yet. It is said to work really well for soap making. In 4 to 5 months, when I'm low on soap again, I'll try something new and share how that went. I waited a month till the soap fully cured, then as we used it I took some pictures. Thanks for watching.